Assalamu alaikum, everyone. Let's get started with the idea of M1, the syllabus overview, and I hope the voice is all good and everything. So now in this overview, the focus on doing a bit of each chapter. So let's start with kinematics. Now, when we talk about kinematics, it's about the idea that it is about a particle is in motion. And there are two kinds of kinematics that we deal with. The first one is about constant acceleration. So when it's about constant acceleration, then we use equations of motion. We can use coordinate geometry. And what is happening over here? That is that if these are the symbols, and then we can talk about the thing. Let me just double check one thing. Yes, the voice is on. Okay. So now we can talk about the equations of motion, constant acceleration, and so on. So T is the symbol for time, U for initial velocity, V for final velocity, A for acceleration, S for displacement. Now keep in mind, it's velocity and its displacement. These are vector quantities. They have magnitude as well as direction. The first equation of motion is V is equals to U plus AT. So out of 5 symbols, S is not there. S is equals to ut plus half at square. V is not there, the final velocity. V square is u square plus 2as. T is not there. Average velocity, that's the average of initial and final velocity, and average speed, that is total distance divided by time taken. When they use the word initially, that means time t is equals to 0, starts from rest, initial velocity is 0, comes to rest, final velocity is 0, constant speed, uniform speed, steady speed, acceleration is 0. Returns to the origin, returns to the starting point, displacement is 0. So now this basic question, these are some of the basic questions over here. And let's move to the idea of some past paper questions. Let me just copy this thing and let me paste it over here. And then there are different kinds of questions that we will go over. So over here, this is like a velocity time graph. And a little bit of the area is above, little bit of the area is below. We know from pure maths P1, area above is considered positive. Area below is considered negative. If I talk about distance, take the absolute value and add. If I talk about displacement, then this is positive, this is negative. Now let's first read the question. It says a man runs in a straight line. He passes through a fixed point A with constant velocity 7 meter per second at time t is equals to 0. His velocity is v meter per second. The diagram shows the graph of v against t for a period of 40 seconds. So that's 40. Show that the man runs more than 154 meter in 24 seconds. Now we know that this is a rectangle. If I consider this as a triangle, let me find the total area. And this is that extra area. So that means the triangle and the rectangle should be 154. Since this is unaccounted for, it will be more than 154. Given that the man runs 20 meter in the interval 20 to 24. So whatever this thing is, this is 20 meters. How far he is from A when t is equals to 40, and he started from the fixed point A. That means consider this to be positive, consider this to be negative, and then add it up. So now, first of all, the area of the triangle, that's 14. The area of the rectangle is 140. The total is 154. This is left out. That's why it's more than 154. Now this is 140. Now let me take this whole area as 20 because 14 is already included. 140 plus 20 is 160. Area below is 40. So therefore, the difference is it's going 160 in this direction, 40 meter in this direction. How far is that person away? 120 meters. So that is the basic kind of question that comes. Now, it has been a long time that people have not asked about converting, even though this is O-level stuff, but expect the unexpected. So let me add a page somewhere over here that is in M1, and let me add a page, and this is the orange is for M1, and this is 2026 overview. So now over here, when we talk about this thing, so now it is about that expect the unexpected. That means some kind of basic O-level concept can be asked in M1 and so on. So that is the first thing that you need to take care of. Now, let me just check my WhatsApp because some people were asking about certain thing. And just hold for a second. Okay, let me just share it with some people. Okay, so now that's the first thing that I've written. Then now the next thing over here, that is from the same thing. This thing, let me cancel this thing out. So now from O levels, what I was trying to explain was that we have done questions in kinematics in which a velocity time graph, actually in O levels, it's only speed that is given. And we can convert it into a displacement time graph. We can convert it into a speed time graph. So we know that the area of a velocity time graph, that is displacement. And this thing over here, 70 meters. This is 15 into 4, that is 60 meters. So therefore, this area over here should be 70. This area over here should be 60. And what else is there? So now, first of all, this is displacement. So that is the kind of thing that's done. That means you start from zero. In the first 10 seconds, you cover 70 meters. In the first 10 seconds, you cover 70 meters. Then the displacement does not change. And then you travel 60 meters in the opposite direction because this area is negative. So therefore, 70 minus 60, it is 10 meters away from the origin, just like the question that we just did. Another thing that is, if this is the displacement time graph and this is the connection, this is a separate question. For example, if there is a displacement time graph in the first 20 seconds, 400 meters are covered, next 20 seconds, another 800, last 10 seconds, that is 200. So this is 400, this is 800, this is 200, this is V, you can calculate it. And then that's how a velocity time graph is shown. This is increasing gradient. So the gradient of a displacement time graph is velocity. And over here, this thing is this thing, that is this portion over here, that is zero slope, that is positive slope. That means throughout this region, what is happening? That the speed, the velocity is constant because the slope is constant. Got the idea? So over here, it's increasing gradient. Over here, it's decreasing gradient. So increasing is like this. The velocity is increasing. And then constant slope of a displacement time graph, that is the speed, velocity is constant. And then over here, it is decelerate. Then if I am interested in an acceleration time graph, acceleration is constant. Acceleration is constant. Acceleration is zero. That is how this thing is drawn. Okay, so now these were two important things out of here. Now, a question of something like this. Let me just double check. Yes, a lot of time these kind of questions do come in, and even though they are very simple, a lot of people they get stuck on this kind of question. I would like you to first have a good look at it, and sometimes a blast from the past. They pick something very, very basic from the past and then they give it. because A levels has been in motion for the last 25 years, the current syllabus that we are talking about. So let me write this thing down over here. So sometimes, yes, a lot of people, they ask this question, which years to focus on? So yes, focus on the year 2025, 2024, and 2023. And if you have done all the variants, that's good enough. If you have not done, then pick and choose. So that depends on how much effort that you can put in, how much time is available. So you have to be realistic and don't overdo things. Work with a balance. Use active recall. Whatever you remember, just try things based upon that. And improve on your basics. Show all the working. And I'll soon show uh, the kind of past paper questions that you have done and a lot of things from the examiner report also. Let me first finish off this concept of kinematics. So now over here, let's look at this question. It says a car travels in a straight line from A to B, the distance of 12 kilometers, taking 552 seconds. The car starts from rest, accelerates for t1 seconds at zero point 0.1, 0.3 meter per second square. And then it says reaching a speed of v. So we are over here. And then the car then continues to move at v for t2 seconds and then decelerates at 1 meter per second square coming to rest. So now by this time, you should have a mental map ready that it would be something like this. Got it? Now it says sketch the VT graph. Of course, these are unknown at this point. So in terms of that, you have to sketch it. Express the total distance traveled in terms of V and show that this thing 13v square plus 3312v plus 72,000 is equals to 0. Hence, find the value of v. Now, first thing first, of course, nobody is going to sit down and think of all the middle term factorization. So quadratic formula is the only way. Some person might be too bright. I don't know. Such people exist. But for normal people, you have to use quadratic formula. So now let's have a good look. That's the graph. This is 0.3. That's the slope. This is V. This is the time T1. So this is the time interval. It's not labeling. For the first one, this can be labeled as T1. This can be labeled as T2. This thing is T2. So therefore, this can be labeled as what you call the whole thing 552 minus T1 minus T2. That labeling is there, but I would prefer that you work in intervals. That's the thing. And then the deceleration is 1 meter per second square. So for calculation purposes, that would be -1. So V over T1, that is 0.3. Similarly, V over T3 is -1. Make T1 the subject, that's V over 0.3. Make T3 the subject, that's V over -1. Now, what else is there? Then this thing is 552 minus T1 minus T3. This is T3, this is T1. And if I write this T2 in terms of T1 and T3, that is this much. So this minus and this minus would cancel. Area of trapezium, half sum of parallel sides into height. So this is T2. And this is this one, 552. We work it out, we simplify, just look at all the working, and then we get this thing out. So now that was a special thing about this. This one, yes, this is also important. And another nice question. Now, people first study, and you people can work it out. So let's take a few minutes. Try this out, especially the part 2. That is very, very nice. Okay, so Shall let me solve this one because otherwise then people will think that there is no voice coming or something like that. So let me try this out. Now, first thing first, that is this thing. And let me underline stuff. It says a car starts from rest, moves in a straight line from the point A, constant acceleration for 10 seconds. The car then travels at a constant speed for 30 seconds before decelerating uniformly, coming to rest at point B. The distance AB is 1.5 kilometer. Find the total distance traveled in the first 40 seconds of motion. Now, this is about a car. Okay, that is pretty basic stuff. Then it says when the car has been moving for 20 seconds. So 20 seconds have gone. A motorcycle starts from rest, accelerates uniformly in a straight line from point A to a speed of V. It then maintains the speed for 30 seconds before decelerating uniformly to rest at point B. So the starting and ending point is the same. It's just that difference of 20 seconds. The motorcycle comes to rest at the same time as the car. Given that the magnitude of acceleration A of the motorcycle is 3 times the magnitude of its deceleration, find the value of A. Now, this is the most important part. Sketch the displacement time graph for the motion of the car. So now it's about the car and then the motorcycle, and then again, it's about the car. So now over here, first thing first, that is, I think I've done it someplace else. No. So now over here, if we work this thing out, that is for the car. So now over here, we have this thing 3 meter per second square. And I think I skipped that part. So now this is 3 meter per second square. Let me just make some working over here. So now first thing first, that is like this, and like this. So now 3, 10 seconds. So that is 3 and 10 seconds. So V over 10 is 3. Therefore, V comes out to be 30 at the constant speed for 30 seconds. So therefore, this is 40 now. This is labeling coming to rest at B. The distance AB is 1.5 kilometers. So find the total distance traveled in the first 40 seconds. So the total distance is this much. And then it speed for 30 before coming to rest. So this is half into 10 into 30. That is 150. That is this much is 150. This is 30 into 30. That is 900, 1050. So therefore, this is 450. So this time interval is T. So therefore, 450 is half into T into 30. So therefore, 15 into 2, that is T comes out to be 30 seconds. Okay, double check. So 3 and 3 cancels, 15, 15 into 2. Yeah, this is 30 seconds. So therefore, the total time taken is 70 seconds. Therefore, the time taken for AB should be 50 seconds. So now over here, even though they have not asked us to sketch for part 2, this is the sketch for part 2. So this is for the motorcycle. Now it accelerates at A, and let me call this thing as A1. And it decelerates at A2. So therefore, V over T1, and this thing is V over T2, that is the magnitude, T1 plus 30 plus T2, because it also has this 30 in it. And this adds up to 50. Therefore, T1 plus T2 is 20. That's one equation. The magnitude of A1 is V over T1. The magnitude of A2 is V over T2. And it says the magnitude of A1 is thrice the magnitude of A2. So V over T1 is 3 times V over T2. Therefore, T2 is 3 times T1. That also makes sense because since this is accelerating very fast as compared to this thing, this is slower. So therefore, this time taken will be more, this time taken will be less, and it should be in the same ratio. So therefore, T2 is 3 times T1. Since A1 is 3 times A2, therefore it's the opposite. T2 is 3 times A1. So T2 is 3 times A1. Plug it in over here. Therefore, T1 comes out to be 5 seconds. T2 comes out to be 15 seconds. So that's an important question over here. Now, let's talk about, now this is kinematics over here. And let's use this concept. That's the concept of what you call acceleration due to gravity. Now, this is part of kinematics, equation of motion, constant acceleration, but we treat it separately also and just ignore the value of acceleration, which is negative 9.8. It was depending upon some book, but just focus on the concepts that the questions are nice. Now it says, when a ball is thrown vertically up from a point with an initial speed of 21 and it's later caught again at A. So it's gone up, it's caught again at A. Find the length of time for which the ball is in the air. So there are two ways of doing it. We will take acceleration as to be negative g. Final velocity is 0. When it reaches a maximum height, it slows down, stops momentarily. So that's where the final velocity is 0. We find the distance. And what is the time taken to reach? That is 2.14 seconds. So the time to go up should be the same thing as time to come down, because it's the same acceleration which is speeding it up, and it's the same acceleration which is slowing it down. That's one way. The other way, that is displacement is 0. So S is equals to ut plus half at square. Displacement is 0. We simplify, we get the total time. Time t is equals to 0 at the beginning. That means when this journey started, it was initially at the starting point, and going all the way back, it's back at that point. So this is also related to quadratics. Okay, so a lot of these things are related very much. Now, another simple question, it says, a stone is projected vertically up from the ground level at the speed of 24.5. Find how long after projection the stone is at a height of 19.6 meter above the ground for the first time. For the second time, how long is the stone at least 19.6 meter above the ground? So now A is negative g, u is 24.5, displacement is 19.6. You solve this quadratic equation, you get two answers. So when you get two answers, that's 1 and 4. That means it was initially over here. At 1 second, it reaches this point, and then 2 seconds, and then 3 seconds, and then 4 seconds. It's back at the same level. So 1 and 4. And then what is happening over here? So 4 minus 1 is 3. For 3 seconds, it was above this height. That is the basic idea. Let me talk about something about displacement. Yes, very important. That is, I think if I've done it this way, yes. So now over here, I've done it in two ways. A stone is thrown vertically up with a speed of 20 meters per second from a point at a height h meters above the ground level. If the stone hits the ground 5 seconds later, find h. So there are three parts of the journey. The first part of the journey is reaching a maximum height. Second part of the journey is coming back to the same level and then falling all the way to the ground. So now the first thing is that u is 20, acceleration is negative g, final velocity is 0, distance is 20.4, and the time taken is how much? The time taken is 2.04. So I have calculated it over here. Now, so 2.04 seconds to go up, 2.04 seconds to come down to the same level. So 5 minus 2.04, 2.04 is 0.92. So now the speed with which it was thrown is the same speed with which it possesses at this level. So now that is 20. Time is this. It's going down. Acceleration is plus g. And then we can find the distance that it travels. That distance is 22.55. That's the first thing. The next concept that comes in very handy, that is called the concept of displacement. That means in such a situation, when it will go up, come back to the same level and drop all the way to the ground, in such a situation, we will take u to be positive because it's going up. Acceleration is against it. That is why it will reach a maximum height and then come back to the same level and then go all the way to the ground. So acceleration is negative and displacement is negative because this is like the x-axis. So this thing displacement is positive, it's going down, displacement is negative. So that's called the concept of displacement. Always take initial conditions. If I apply this concept, I'll get the answer directly. Yes, I won't be getting the time taken. I won't be getting the maximum height. That I have to resort to the previous method. So that is the kind of thing that's done over here. Now let's move to something else. Let me focus on this. Something like this. A ball A is released from wrist at the top of a tall tower. 1 second later, another ball B is projected vertically up from the ground level near the bottom of the tower with a speed of 20 meters per second. So one thing is falling down, the other one is projected upwards. The two balls are at the same height 1.5 seconds after ball B is projected. Show that the height of the tower is this much, 50 meters. Find the length of time for which ball B has in motion when ball A reaches the ground. Hence, find the total distance traveled by ball B up to the instant that ball A reaches the ground. Now, this is kind of a little bit tricky. So now over here, when it says it's released, initial velocity is 0, acceleration is plus 10, displacement is 31.25 meter. And what else is there over here? Now this particle is going up. It meets after 1.5 seconds. It says the two balls are at the same height 1.5 seconds after ball B. So this one goes down this much distance. This one goes up this much distance. If I add these two, then this total is 50 meters. Find the length of time for which ball B has in motion. Ball B is the one projected up. So now when ball B is going up, it will reach its maximum height. Right now, particle A is 31.25. So it has gone down 31.25. Now 18.75 meter is left. What is the velocity at this instant and how much time will it take to reach the ground? So initial velocity is 0, or you can start from the beginning. Distance is 50 meters. Acceleration is plus 10. Time comes out to be square root of 10. And for particle B to reach the maximum height, final velocity is 0, and it comes out to be 2 seconds. So now it says that maximum 0, A is 10, and this is 0.16 seconds. So now S is equals to 0.128, maximum height is 20 meters. So basically this is 3.16, and it takes 2 seconds to reach the ground, and 3.16 minus 2 is this much. T is equals to 0.16, and based upon that, we will find the total distance. Now, let me just show you the working. This is 2.16, reaches a maximum height in 2 seconds, distance is 20 meters. And now what is happening is that this 2.16 and this 2 seconds, the difference is 0.16. And how much will it go further down like this? So 20 meters going up, 0.12 meter going down. So total distance is these two added together, 20.128. So this is a little bit mixed up over here. It's an old working. So that is what is shown over here. Now let's talk about kinematics of variable acceleration. So when it's constant acceleration, use equation of motion. When it's based upon area in terms of t, not area, acceleration in terms of t, velocity in terms of t, displacement in terms of t. So now acceleration is no more the scenario. So if it's constant acceleration, equation of motion. If it's variable acceleration, so constant equation of motion is not applicable. So now you have to use differentiation, you have to use integration. So differentiate displacement, you get velocity, differentiate velocity, you get acceleration, integrate acceleration, you get velocity, integrate velocity, you get displacement. So that's the concept of first derivative, second derivative, and all these things. So now let's look at this first question. And once we are done with this kinematics, I'll first read out some things from the past papers. So now it says a particle P moves in a straight line and it passes through the origin O. The velocity of P at time t seconds is such and such. So sometimes they can give us a velocity equation, they can give us a displacement equation, they can give us a equation of acceleration. At time t is equals to 0, the particle is at rest at point whose displacement from O is negative 36. So now this is like a condition for integration. Remember, when you integrate something, you have to evaluate a constant of integration. So this is that knowledge. Find an expression for the displacement. Find the displacement of P from O when t is equals to 4. Find the values of t for which the particle is at O. So now first thing first, integrate. You get the displacement equation. You have plus c. So now when you have plus c, think about it. What you need to evaluate. So you have to plug in some displacement. You have to plug in some time. So in order to evaluate c. So that thing is this thing. It says at time t is equals to 0, the displacement is negative 36. So at time t is equals to 0, let me write over here, t is 0, displacement is negative 36. We get c to be negative 36. So now we have this displacement equation that's right over here. And then let's proceed. The next thing, find the displacement when t is equals to 4. So when t is equals to 4, displacement comes out to be this value. Just plug in and evaluate. Particle is at O, that means displacement is 0. So solve this disguised quadratic equation and you get the relevant answers. Okay, now another question. Let me first show you the question so that you can have an idea exactly what's going to happen. Okay, again, read this question first. And let me underline it. So now it says a particle starts from rest, point A, travels in a straight line until it reaches a point B. Velocity of the particle is such and such. Now I hate all these zeros because they are so difficult to see. I mean, big numbers, that's no issue, but these zeros, be very, very careful. Given that the velocity of the particle when it reaches B is 0, given that velocity of particle when it reaches B is 0, find the time taken for the particle to travel from A to B, the distance AB, the maximum velocity of the particle. Now, few pointers over here. Whenever they ask about maximum of minimum of any quantity or equation, it could be area, it could be volume, it could be something, then derivative of that quantity is not the right word, that equation should equal to 0. That's the rule. So if they say maximum velocity, therefore derivative of velocity should equal to 0. If they say maximum displacement, then derivative of displacement, which is velocity, equals to 0. If they say maximum or minimum acceleration, so derivative of acceleration equals to 0. So that's a very, very important rule that you need to remember. Now let's see how it goes. The second thing is this thing. If this is a velocity time graph, this is velocity, this is time, whatever the graph is drawn. And it's starting from, let's say, A, it's going till B, whatever the values of time are, and I need to find the distance. That's the concept of area under graph. So that is area under graph. So a lot of P1 concepts are applied in M1. And the same goes for S1, the same goes for S2. The time taken for the particle to travel from A to B, let's see. So now over here, the very first thing is that its velocity drops to 0 at B. It's starting from 0. It's ending at 0. We don't know the time. So therefore, take t square common out. You have this thing. You could also have taken all these zeros things common out. This thing equals to 0. That's the beginning. T is equals to 90. That is the time taken. Now, in order to find the area, there are two ways. The first way that I just gave you a brief overview, that is integrate the function between the limits. Don't have to worry about constant of integration. You will get the area. The second method, and sometimes they ask for this specifically, is to find the displacement equation. Integrate this function. There is a plus c. So I'm integrating it. There is a plus c. And that c comes out to be 0. So therefore, we use this equation, plug in the value of 90, you will find the displacement. That is the basic idea. So now over here, let me show you some past paper questions, something like this. Have a good look at this question. So I'm just writing over here kinematics. And this is almost done. So now over here, it says a motorcyclist starts from rest at A, travels in a straight line. For the first part of the motion, the motorcyclist's displacement is given by such and such. Sometimes they give the variable as S, the letter S, and or sometimes the letter X. Show that the motorcyclist's acceleration is 0 when t is equals to 50 and find the speed at this time. So now we have the displacement equation. So that is this thing, which is x in terms of t. We differentiate, we get v in terms of t. We differentiate again, we get a in terms of t. Now this is kind of verified. So t is equals to 50. You plug it in over here, we get a 0. And when t is equals to 50, you plug in the velocity equation, we get 30. Now it says for t greater than or equal to 50, the motorcyclist travels at a constant speed of v meter per second. So first it's variable acceleration, then it's constant speed. So maybe it's a flat line like this. Not maybe, it is. Find the value of t for which the motorcyclist's average speed is 27.5 meter per second. Just for reference, average speed is total distance over time taken. So now, first of all, between 0 and 50, we can find the distance covered, that is 1000 meters. So now look at the shape of the curve. This is a quadratic. So knowledge of quadratics is assumed. This is positive t square. So it was starting from origin. The shape is like this. And what else is there? Then when at 50 seconds, it reaches the speed of 30 and then it travels at this thing. So now this area is 30t. So this is 50, this is t, the total time is 50 plus t. Total distance is 1000 plus 30t. And then the time taken is 50 plus t. Average velocity is 27.5. So total distance over time taken is this much, and t comes out to be 150. Therefore, 150 is the value of t. 50 seconds have already passed. So therefore, 50 plus 150, that is 200 seconds. Now, another classic question, a very, very classic question. And again, you should have a good idea of how to handle different kind of questions. And I'll talk about some examiner's expectation also. Just have a good look. First, read through the question. Now it says a tractor journey starts from rest, travels along a straight road for 500 seconds. The VT graph shows for the journey is shown above. The graph consists of 3 straight line segments. Find the distance traveled by A, find the initial acceleration of A. Now this first part, that is a constant acceleration because of all these straight line portions, segments. So now over here, let's focus on this. That is, this one is a triangle. So that's half into base into height. This one is a trapezium, half sum of parallel sides into height. This one is another triangle that's over here. Total distance covered is 2160 meters. Acceleration during the first 4.8 seconds, that is 4.8 over 100, that comes out to meters. 3 marks, 2 marks, 5 marks, very easy 5 marks. So variable acceleration, that's the next 8 marks. Now it says another tractor B, that is tractor A, this is tractor B, starts from rest at the same instant as A, travel along the same road for 500 seconds. Time is also the same. Its velocity is given by such and such. So now as soon as they give you a velocity equation in terms of t, or for that matter, a displacement, for that matter, an acceleration equation, that means what is it about? It's about differentiation integration. How much greater B's initial acceleration is than A? So initial acceleration of A, we have it. If I differentiate and I plug in a value that will value of t is equals to 0, that will give me initial acceleration. Then I'll subtract. That was basic stuff. How much further B has traveled than A at the instant when B's velocity reaches its maximum? So maximum velocity, derivative of velocity equals to 0, acceleration equals to 0, and then we will work it out. Now let's focus on this. The very first thing, we have velocity equation, we have acceleration equation. Initially means t is equals to 0, acceleration comes out to be 0.06. This is 0.048, this is 0.060. That's the difference. That's for 2 marks. So these 2 marks were also easy. Maxima, minima of anything, derivative of that thing equals to 0. Velocity maximum, derivative of velocity equals to 0. That is the derivative of velocity right over here, which is acceleration equal to 0. You get 250 seconds. How much further B has traveled than A? Now there are two things to consider. The first thing is that at 250 seconds, how much distance has it covered? So we have the distance for first 100 seconds. At 250 seconds, I first need to evaluate V. Based upon that V, I'll find this distance. And how can I find that V? Using the concept of collinear points. That is one point is 100, 4.8. The other one is 300, 7.2. This is 250, V. So that is giving you the sneak preview. First of all, displacement of B in the first 250 seconds using integration, that comes out to be 1250. Over here, collinear points that I just talked about, and this V comes out to be 6.6. When V is 6.6, what is the distance? First of all, this is 250, 240, and this is 855. So this distance is 240 plus 855, that's 1095. This distance is 1250. The difference is 155 meter. So that is another great question. So now this was all about kinematics. Let me take you over here. That is, in kinematics, what is the rule that we are following? So in kinematics, first of all, let me draw this thing. That is, there are two kinds of kinematics. The first kind of kinematics is kinematics 1.0. Let me call it kinematics 2.0. Of course, that's not the official numbering. I'm just doing it. Over here, constant acceleration. Over here, variable acceleration. When it says constant acceleration, therefore, yes, equations of motion, they are perfectly valid. And equations of motion, they are no longer valid, not applicable. The next one, that is, you can also use coordinate geometry. You can use the concept of 2D mensuration, 2D area, and then basic slope and all these things. That's the kind of thing that's used. Over here, you have to use differentiation. You have to use integration. You have to use an integration that is derivative function giving you velocity. That is plus C you have to take care of. You have to take care of area under graph. That is the concept that you need to take care of. In differentiation, you have to take care of the concept of stationary points. And of course, there are some common things between the two. That is the word like initial, the word like starts from rest, comes to rest, comes back to starting point. So these are comes back. That's not stationary point, starting point. So hold for a second. So these are some of the common things that is about kinematics. And I have done some basic stuff which will give you a clarity of concept over here. So this thing is done. Now over here, let me focus on some other thing. But before that, I'll be taking a short break. But before that, let me first focus on this thing. So now this is S2, my bad. And this is 1, 2, 3, 4. That is S2, and this is M1. Now in mechanics, there are some things that you need to consider. That something is this. Let me just highlight it. So this is from the very, very recent paper, that is June 2025. And I'll also read few of November 2025. They all basically tell you the same story. They tell you the story is that humans don't learn from mistakes, but you should be the one who should be learning from mistakes and do not repeat it. Now it says, when answering questions involving any system of forces, a well-annotated force diagram could help the candidate to include all relevant terms when forming either an equilibrium situation or a Newton's law equation. Such diagram would have been particularly useful in some particular question. So that's the first thing. That is, a diagram is a must. And when we will look at some of the concept of forces, you will soon realize it. The next thing is, non-exact numerical answers are required correct to 3 SF or angles correct to 1 dp, the same thing as in P1, the same thing as in P3, as stated on the front of the question paper. That is the instruction thing. Candidates are strongly advised to carry out all working to at least 4 SF if a final answer is required to 3 SF, or in the case of angle, work at least in 2 dp. And then it further says, in questions such as question 7, where displacement is given as a function of time, calculus must be used. Differentiation and integration collectively is called calculus. It's not possible to apply the equations of constant acceleration, just told you right now. So now let's move on over here, the next paper. I think it would be same story, more or less. So now let's focus on this. When answering question, any system of forces, a well-annotated force diagram, it's the same thing. Velocity is given as a function of time, then calculus must be used. The same thing, non-exact, the same thing. It's exactly the same thing that's written over here. Let's see if there is something different. So now over here, when answering question, any system, again, the same thing, the same thing, the same thing. It's the same thing. So let me just go to some thing over here. That is S2, my bad. And this thing is S1. And over here, that is M1. That is the June thing. I'm just looking for November thing. This is, okay, for some reason, it's getting stuck. So this is S1. Okay, let's look at this. This is a November paper. Non-exact numerical answers, the same thing. Again, they are talking about calculus must be used when velocity is given as a function of time, system of forces. So it's the same old story that you have to take care of. So let's just figure it out. And I'm just looking. Okay. So let me just focus over here. Now, let's do a bit of force things first. So now in forces, the main thing is about resolution of forces. And you know the basics. I'll just start from here. The way that I teach it is that angle should be with the horizontal. So the horizontal component is always cos, the vertical component is always sine. So this is 50 degrees. This is 5 Newton. 5 cos 50 in this direction, 5 sine 50 in that direction. The original force should be sandwiched between the components. If this is 6 Newton force, 6 cos theta should be in this direction. 6 sine 30 should be in this direction. A force that is horizontal needs no resolution. A force which is vertical needs no resolution. Three coplanar forces acting on the same planes, on the same surface. Magnitudes are such and such. Find the magnitude and direction of the resultant of the three forces. So resolve each force. Then this thing over here, this is going to the right, this is going to the left, this is going to the right. So this is over here, this is left, and this is right. So this is positive, this is positive. These two will add up. This will be subtracted. That's the overall answer, positive. That means overall the horizontal component is to the right. And then this one is going up. This one is coming down. So this is 0.8302. So therefore, this one is 5 Newton in this direction, 0.8 Newton in this direction. The resultant should be in this direction. That is based upon Pythagoras theorem, and calculate the basic angle. That is the direction it makes with the horizontal. That is the basic idea. Sometimes you have a question like this, another examiner's favorite. It says the three coplanar forces shown in the diagram act at a point P are in equilibrium. So when they're equilibrium, the easiest way that I teach you is that the rightward forces should equal the leftward force, the upward should equal the downward. So don't apply any positive negative sign over here. That's the strategy that I employ. So now this is F over here, this is F cos theta, this is F sine theta. This is 12 over here, this is 12 cos theta, this is 12 sine theta, and this 10 Newton is acting vertically downward. P is a point. Find the values of F and theta. So if I make F cos theta the subject, that's this thing. F sine theta plus 12 sine 30 is 10. So therefore F sine 30, F sine theta is 4. So this is sine, this is cos. Sine over cos is tan. So therefore 4 over 6 root 3 is tan. Hence you find the value of theta. Plug in one of the equation, you find the value of F. Now it says state the magnitude and direction of the resultant force at P when the force of magnitude 12 Newton is removed. So if I remove the force of 12 Newton, so basically 12 was balancing these two, correct? So 12 Newton is balancing these two. So basically this and this were equal. If this thing is removed, we only have this force. So 12 Newton, that's a resultant. It's making an angle of 30 degrees with the x-axis. That is the basic idea. Let me look at some more questions. Something like this. Let me just copy this thing. Now it says a very famous question. That is this thing. Each of the three light strings has a particle attached to one of its ends. The other ends of the string are tied together at point A. So that's where the strings are tied. The strings are in equilibrium with two of them passing over the fixed smooth horizontal pegs. So this is a horizontal peg, this is a horizontal peg. The weights of the particle and the angles are given. Find the values of W1 and W2. So this is W1, therefore this is W1. So you can draw it like this, you can draw it like this. These two are the same, you can draw it like this. So basically it's one single string passing over the pulley, so it's one single tension. Another string, another tension. And then basically at this point, we have this thing, let's call it T1. We have this thing, let's call it T2. We have 5 Newton, and that is exactly like the question we just did. Have a good look at the working. Now, what have I changed over here? I have changed this thing that I have taken angle with the horizontal because that's how I'm used to working. Everyone has their own scenario. There is no right and wrong in this. So now this is 50 degrees. First of all, W1 is T1. That is the first thing. This is T1 and this is T1 cos 50. This is T1 sin 50. This is T2. This is T2 cos 30, T2 sin 30, and this is 5 Newton. So now I'll write this thing. T1 cos 50 is T2 cos 30. This equals to this. It's in equilibrium. And this plus this equals to 5. And once I get the value of T1 and T2, so T1 is the same thing as W1, T2 is the same thing as W2. So you can work in your own symbol and then change at the end. So now let's talk about this thing. Yes, inclined plane, very necessary, very necessary. So this is the background knowledge. Let me just start from here. That is, if there is a weight on an inclined plane, we are not talking about smooth or horizontal at this moment. We are just talking about the weight component of this particle on the plane. First of all, it's a weight component. It's not mass component. So W is equals to mg. Down the plane, it is W sine theta, which can be written as mg sine theta, where theta is the angle with the horizontal. And perpendicular to this should always be mg cos theta. That's the first and foremost rule. The second thing, now some scenarios, and these scenarios are very, very important. They will help you get your A star. So now over here, case number one, it's a smooth inclined plane. There are no external force. Weight is acting downwards. This particle will slide down. It will accelerate down. This R is the normal reaction force. Normal over here is the same normal. The tangent and normal, that normal, वो वाला normal है ये. ठीक है ना? So this is perpendicular. Can it be in equilibrium? Not possible. So now over here, mg sine theta minus 0, there is nothing stopping it. Mg sine theta is equals to ma. So m cancels. Therefore, a is g sine theta. So we get this idea whenever there is a particle, it's going down the plane. So acceleration is the gravity, acceleration due to gravity multiplied by the weight component multiplied by sine of theta. You review, you remove that m and you get the acceleration. R is equals to mg cos theta. That is of no use to us at this moment. Now, next one, next scenario. I'll just focus on the scenarios. That is external force acting parallel to the plane. So external force is acting parallel to the plane. Therefore, R is this and P is mg sine theta. If it's an equilibrium, P sine theta, P is mg sine theta. Now there are two possibilities. Either the particle is going down, that means this is greater than this. The resultant force is the difference, that's mass into acceleration. Or the particle is moving up, that means P is greater than mg sine theta. P minus mg sine theta is ma. So now those people who are watching, just acknowledge a bit on the comment section. So if this is all good, the most important part. So therefore, over here, this is P cos theta, this is P sine theta. Now let's apply this knowledge over here. Now have a good look at it and think of all the possibilities that you can think of. What about equilibrium? What about moving up? What about moving down? And right now, this is all about a smooth plane. Keep that in mind. So now over here, I'll just show you from here, from the diagram. This is R, that's acting up, P sine theta acting down, mg cos theta acting down. So R is P sine theta plus mg cos theta. That's the first thing. That's fixed. This is going up. Mg sine theta is going down. So now if this is greater than this, the particle will move up. If mg sine theta is greater than this, then the particle will move down. If it's an equilibrium, both things will be the same. Got the idea? Okay. Now, a nice question. Just focus on this, another one of the examiner's favorite. And just have a good look at it. Now it says, a small block of weight 5.1 Newton rests on a smooth plane inclined at an angle alpha to the horizontal. Sine of alpha is 8/17. The block is held in equilibrium by means of a light string. The string makes an angle of beta above the greatest slope, and sine of beta is this much. So there is sine of alpha, there is sine of beta. Two things are there. Find the tension in the string. So now over here, what needs to be done is this. That first of all, let me write on that page, which is about all these important details. That is, when we are talking about this force thing. So no, not this thing. And over here. So now, when we are talking about forces, so some things that we need to consider, and we'll come back to that in a short while. That is, diagram is a must. A well annotated, labeled diagram is a must. Without it, don't expect a nice grade. Second thing, what is it about smooth versus rough? Is it about equilibrium versus acceleration? Is it about horizontal surface versus incline? Versus sometimes it's also about a bar or a rod. We have seen questions like that. Over here, trigonometry, exact trig ratios are very, very important. And sometimes it's also asking about Newton's laws of motion. That thing also will be coming up. And of course, the most important thing, it's about resolution of forces. And unless and until this thing is correct, don't expect any miracles to occur. So these are some of the main things that you will commonly see. So now coming back to this, let's look at the working. This is like case number 4. It's a smooth plane. First thing first, sine of alpha is 8/17. Use Pythagoras theorem. This comes out to be 15. Therefore, cosine of alpha is 15/17. Another one, beta. Sine of beta is 7/25. Again, you get this thing, which is 24. So we have sine beta, we have cos beta. These are some of the common angles that we come across. Okay, now over here, this force in the string needs to be resolved. So this is t cos beta. That's the exact value. T sine beta, that is this thing, t into 7/25. Normal reaction force is there, weight component down the plane, mg. So 5.1 is already Newton. If it was kg, we would multiply it with 10, but it's already Newton. That means it was 0.51 kg into 10, that is 5.1 Newton. What the idea? So this is weight down the plane, this is weight perpendicular to the plane, and it's in equilibrium. So r plus this equals to this. That's the first equation. The next equation, t cos beta is equals to 5.1 sine alpha. T cos beta is 5.1 sine alpha, and just look at all the working. So this is not just force working. This is like trigonometry in the highest form. A conceptual question of trigonometry, the exact trig ratios, all these things are over here. That is one very important question. Another important question is this one. So now it says small block A and B are held on a smooth plane inclined at 30 degrees to the horizontal. That is 30 degrees. Each is held in equilibrium by a force of magnitude 18 Newton. The force A acts upward parallel to the line of greatest slope. So this is acting upward. That is case number 2. And the force acts horizontally. That's case number 3. That's acting like this way. So if this is 18 Newton, this should be 18 cos 30, and this is 18 sine 30, what I just told you. So now for case 2, that's the force diagram. For case 3, that's the force diagram, and you can see the equations for yourself. Just focus on this one. The purple thing is that particle. Okay. So now this thing is done. Now comes the idea of friction. So I was going to give you a break, but let me just move ahead a little bit, and then I'll give you the break. That is this thing. There are two very important things about friction. The first one is friction always opposes motion. So it will always be in the opposite direction of motion. The second thing, friction always acts parallel to the surface. So if it's a horizontal surface, it will be on that surface. Start tilting the surface, the friction will be moving on that surface only. So now F max is equals to mu r. So first in friction, the most important thing is that you need to get r. Once you get r, multiply by mu, you get F max. That is the first thing. Now let's look at this question. Very, very important question. Again, this hasn't been tested for a long while, so expect something like this. So in the meanwhile that we are studying, I'm also focusing on these things which are very, very important. So now over here, it says a block of mass 2 kg is at rest on a horizontal floor. So this is a horizontal floor. The coefficient of friction between the block and the floor is mu. A force of magnitude 12 Newton acts on the block at an angle alpha, where tan alpha is 3/4. So this is acting towards this. This one is acting away from this. When the applied force acts downward, the block remains at rest. So we are talking about figure 1. Show that mu is greater than or equal to 6/17. When the applied force acts upwards, so this is like a push, this is like a pull. The block slides along the floor. Find another inequality for mu. Now, first of all, this is 12. This is 12 cos alpha. This is 12 sine alpha. This is R F max, since it has a tendency of moving to the right, whether it's moving or not. So therefore, F max opposes motion. And over here, that I'll do a little bit later. Hold for a second. So now over here, why is it showing like this? So tangent of alpha is 3/4. Sine of alpha is 3/5. Cos of alpha is 4/5. R plus 12 sine alpha is 2g. So R is up, 12 sine alpha, that is going down. That is this green one. And this is this 12 sine alpha plus 2g, that's R. 12 into 3/5 plus 20, that is R. F max is mu R. So this is like 12 into 3 is 36/5. 5 into 20 is 100. 136/5. That is a 1 over here. This is 136/5. So now P is 12 cos alpha. We also have alpha. So now if it's not moving, what does it mean? It means the applied force is either less than or equal to F max. That's the concept of limiting equilibrium. And that gives me this thing. That's the first thing. Second thing over here, now R is acting upwards. 12 cos alpha to the right, 12 sine alpha up, R is up, 2g is down. Now R plus 12 sine alpha is 2g. Now the value of R will be lesser. This is 64/5. Look over here. This is 136/5 because of that push and the pull. F max is mu R. That is this much. So now it is moving to the right. That means this is greater than this. We just need the inequality. So P is greater than F max, therefore mu is less than 3/4. That's the other inequality. One inequality is traveling in the right direction, inclusive. The other one is traveling in this direction, non-inclusive. So mu lies between these two. So now inclined plane, rough surface. The same thing as we have studied, but this time there is, first it was this, this, and this in case number 1. Now, if it's a rough surface, friction will oppose motion. Friction will act parallel to the surface, no external force. Therefore, R is equals to this, mg sine theta equals to F max. So now if it's in equilibrium, mg sine theta is mu mg cos theta. And if it's moving down, so mg sine theta minus F max is equals to ma. Move up, nope, that's not possible. Friction can oppose motion. Friction cannot initiate motion. That is the most important thing. Similarly, external force acts parallel to the surface. If external force acts parallel to the surface, then there are two tendencies. First of all, let's talk about limiting equilibrium. So R is equals to this thing. That is F max is mu R. Okay. And mg sine theta is P. Now, limiting equilibrium, now what we can say that there is this thing which is not drawn over here, which is what? Which is friction. Now the friction direction will change. About to slide up, friction is down. About to slip down, friction is up because friction opposes motion. So if friction is down, mg sine theta is down, P is equals to this plus this. If it's about to slip down, friction is up. So therefore, P plus F max is mg sine theta. If there is motion and it is sliding up, that means F max is still down, but P minus F max minus mg sine theta is mass into acceleration. If it slips down, mg sine theta minus P minus F max is mass into acceleration. Now, instead of P, if there is a force like this, of course, you will be doing the component and the same strategy will follow. So have a good look at this. Okay, so let me remove this thing. Okay, the rod question, very famous one. Let me first show you this thing. And after this question, I'll take a break. And you should also take a break of like 10, 15 minutes. And then we will continue. Now, this is a question. They haven't asked this thing for a very, very long while. So let's just focus on this very, very well. So this is that famous rod question. It says a ring of mass 1.1 kg is threaded on a horizontal, a rough horizontal rod. So let's highlight this thing. So this is a rough horizontal rod. Now it says a light string is attached to the ring and the string is pulled with a force of magnitude this much. So that is the string over here and it's being pulled in this direction. Where tan alpha is 5 over 12, the ring is in equilibrium. Find the frictional component of the contact force. Find the normal component of the contact force. So contact force is a combination of F max and R. And given that the equilibrium is limiting, find the coefficient of the friction between the ring and the rod. Now let's look at the working. First thing first, that's the surface. R is acting up. This is the ring. R is acting up. It has a tendency of being pulled to the left. Therefore, F max is to the right. The weight component of 13 Newton, this is 13 cos alpha, that comes out to be 12. This is 13 sine alpha, that comes out to be 5. Tangent alpha is 5 over 12. Pythagoras, you get 13. Sine alpha 5 over 13. Cos alpha 12 over 13. 13 cos alpha is 12. 13 sine alpha is 5. Yes, you have to work this out. Now, F max is 12. That's the frictional component. R is this thing, 13 sine alpha, which is 5 plus 11. That comes out to be 16. F max is mu R. This is F max. This is R. You get mu from here. So now let me stop the stream over here. And let's take a 10, 15-minute break. So let's take a break of 10 minutes. So this is a break of, let's say, 12 minutes. And let's be back in 12 minutes. Assalamualaikum everyone, welcome back. So let me just erase this thing and let me write it over there. Okay, so let's get started. So we talked about all these things, and now let's talk about a little bit of Newton's laws, and let's talk about work energy power and momentum. So now these are the three topics that we need to revise with such questions like these. And yes, there are some past papers which are solved on my channel, not all of them, but some of them are there. And I might be solving one or two more. So you can also check them out. So now over here, when we apply this concept of laws of motion, what do you see over here? We see that if a particle is at rest, so therefore we have T is equals to mg, where T is the force in the string. So if it's moving with constant velocity, that is also the same thing. Okay. So now over here, if it's moving up, that means T is greater than mg. So basically, it's a concept of F is equals to ma. Resultant force is mass into acceleration. And if it's moving down, mg minus T is mass into acceleration. Then what else is here? That's the same thing over here. Just the basic idea. Yes, all these things. When we talk about connected particles, it is called a system. As long as the string is taut, T-A-U-T, stretched out, it is a system. It has a common acceleration. One string, one tension, two string, two different tensions. For the police, it's always smooth and fixed. For the string, it's always inextensible and light. So that is the hard and fast rule. Now, if I look at a question like this, so let me first explain you a few questions from here. And that's over here. So it says particles P and Q are masses of 0.6 and 0.2 kg respectively. Ends of a light, inextensible string passes over a smooth fixed peg or pulley. The particles are held with the string taut. So they both are at the same level, 0.9 meters above the ground. The system is released and each of the particle moves vertically. The acceleration of P, tension before P reaches the ground. So P is the heavier one, P will go down and Q will go up. Find the time taken for P to reach the ground. So now look at all the working. I want you to analyze it. So first on the right hand side, that is 0.6 G minus tension is 0.6 A. For this particle, I make a single equation. For this particle, I make another equation. When I add both of them, I get the equation of the system. So this is for particle P, that is the heavier one. This is particle P. And this is the lighter one, that is particle Q. And this one is for the whole system. Okay, some people, they form the system equation directly and then they go to each particle. It's their prerogative. It's their style of working. I personally believe in particle, maybe two, maybe three particles, and then the system. So what I get is the acceleration 5 and the tension. I can plug in one of the equation. I get this to be 3 Newton. The time taken for P to reach the ground. So now initial velocity is 0. So that's the initial velocity 0, acceleration is 5, distance is 0.9, V is 3 meter per second, V is equals to U plus 80, that is 0.6. Or I could have used S is equals to UT plus half AT square. I personally prefer these two equations, so that's why I use it. Now, another question like this. Particle A and B of mass 0.5 and mkg respectively are attached to the end of a light and extensible string and horizontal floor. Equilibrium moves vertically. A hits the floor. So now this is heavier. This will go down. This one will go up. The speed of each particle when A hits the floor, that is the speed of the system, is 5 meters per second. For the motion while A is moving downwards, the acceleration of A, the tension, the value of M. Nice question. So now over here, the first part is 0.5 G minus tension is 0.5 A. So it's going down. It's going up. T is greater than mg. T minus mg is ma. 0.5 G minus mg is 0.5 plus m into A. Now the value of A is given. How is the value of A given? That we calculate from here. Initial velocity is 0, acceleration is unknown, time is 2 seconds, final velocity is 5, you get A is equals to 2.5. So now plug this thing over here, you'll find the value of N. So it's the same question as before with a slight twist. Something like this thing. A particle on the table, another particle hanging freely. So it could be a smooth table, it could be a rough table. So now over here, what's the scenario? The scenario is if it's a smooth table, this one will go down, this one will move to the right. If it's a rough table, you have to overcome friction. So if it's hanging freely, for the smooth surface, mg minus tension is m1a, this is m1g. And for this particle, m2g is acting down, r is acting up. These two are equal. There is nothing stopping t from particle B from sliding down because t is pulling it. So t minus 0 is equals to m2a. When I add these two equations, the t cancel out. m1g is m1 plus m2 into a. If it's a rough surface, t minus f is m2a. That F could be a constant resistive force. That F could be F max as mu R. Something like this. Have a good look at this question. It says particles A and B of mass 0.4 and 0.1 kg respectively are attached to the ends of a light and extensible string. Particle A is rest on horizontal table with string passing over a smooth pulley at the edge of the table. Particle B hangs vertically below the pulley. The system is released from rest. Subsequent motion, a constant frictional force. So there is a constant frictional force or resistive force. Find the tension. Find the speed of B, 1.5 seconds after it starts to move. Now, what needs to be done first? Let's focus on this. R is 0.4 G. Then over here, 0.1 G minus tension is 0.1 A. Tension minus 0.6 is 0.4 A. And I get acceleration is 0.8, tension is 0.92, initial velocity is 0, acceleration is 0.8, time is 1.5, I find the velocity. Very simple. Now I'm looking for something. Yes, this is again important. Question number 5. It says particles P and Q are attached to the opposite ends of a light and extensible string. P is rest on a rough horizontal table. The string passes over a small smooth pulley which is fixed at the edge of the table. Q hangs vertically below the pulley. The force exerted on the string by the pulley has a magnitude of 4 root 2. Force exerted on string by pulley is the same thing as force exerted on pulley by the string. Got the idea? Force exerted on string. That's the same thing as force exerted on pulley. Show that the tension is 4 Newton, state the mass of Q. Given that P is on the point of slipping, find its mass. A particle of mass 0.1 kg is now attached to Q, and the system starts to move. So first it was in limiting equilibrium. Now there is acceleration. Find the tension of the string when particles are in motion. So now there is one single string. There is tension over here. There is tension over here. And this is like an isosceles triangle because all these lengths are equal. So yes, geometry comes into play. So therefore, this resultant will be making an angle of 45 degrees with the horizontal. So 4 root 2, that's the resultant. 4 root 2 cos 45 is t. This is 4 root 2 sine 45, that is t, or 4 root 2 cos 45 is t. I'm using the exact value. Or if I take this t and join the head to tail method. So this is t, this is t, this is the resultant. That resultant comes out to be a 4 root 2 Newton, and hence you find the value of t as 4 Newton. So different ways of doing this thing. And then what's the next thing? The next thing is this thing, part one, that is T is 4 Newton, MQ is 0.4 kg. And then part two, we are evaluating F max, that is in terms of F, that is in terms of M. F max is mu R. That thing is already done. And over here, F max should equal to T. T is equals to 0.4 into 10. So that's how you find the value of MP. Now the new mass is 0.5 kg. Write down the equation of the motion. 0.5 g minus tension is 0.5 a. Tension minus F max is 0.5 a. And then we find acceleration as this, tension as this, and F max as mu r. So you can find the value of F max. Now, if I talk about inclined plane, so let me do two questions on inclined plane. This one is the first one, I think is 30. Is it the same one? Yes, it's the same one. So that is the question right over here. Why don't you go ahead and first read the whole question? So now it says a smooth inclined plane of length 160 centimeter is fixed with one end at a height of 40 centimeter above the other. So now some basic trigonometry can be used, that the sine of theta is 40 over 160, sine theta is 1/4. And the particles have their masses. A small smooth pulley, rest, and then it says 30 centimeter above the ground, released from rest, and so on. Is it a smooth plane? Yes, it says in the beginning a smooth inclined plane. The acceleration of the particle and the tension in the string before Q reaches the ground. The speed with which Q reaches the ground. The total distance traveled by P before it comes to instantaneous rest. Nice question. So this is like forces. This is like laws of motion combined together. The first thing. This is mg sine theta. This is mg cos theta. This is the normal reaction force. That is the simple weight component. That is tension acting this way, tension acting this way. Now, first of all, it says that the speed, acceleration, tension in Q before Q reaches the ground. So Q is going up, P is going, Q is going down, P is going up. So now 0.49 G minus tension is 0.49 A. Tension minus the weight component is mass into acceleration. And it's a smooth plane. So there is no friction. If there was a friction, so F max would be here. That also needs to be subtracted. Very simple. We get acceleration as 2.4, plug in T, plug in A in one of the equation, you find T. Now, for me, the next part is very important. The speed with which Q reaches the ground, total distance traveled. So now initial velocity is 0, acceleration is 2.4, distance is 0.3 meters, that is 30 centimeter converted to meter, take care of this. And V comes out to be 1.2. Now what happens? That's the main thing, which is when particle reaches the ground, it does not rebound, string becomes slack, there is no more tension in the string, but it has gained some momentum, it would be moving up. So tension is 0 minus the weight component is mass into acceleration. A is g sine theta. Remember, this is g, this is sine theta. That is negative 2.5. Of course, it will slow down. The final velocity of the previous part, which was the velocity of the system, that now becomes the initial velocity. Acceleration is negative 2.5. Naturally, it would slow down to rest. Final velocity is 0. We find this distance as 0.288. So 0.3 centimeter, 30 centimeter, which is 0.3 meter, it goes down. 0.3 meters, it goes up as a system. And then 0.288, it goes up as a free particle, freely moving under gravity. Okay. Let me look at this question. That's right over here. It says particles P and Q of masses 0.6 and 0.4 kg respectively are attached to the ends of a light and extensible string, smooth pulley, and so on. Sine theta is 0.8. So they have given the value of theta, sine theta in decimals. Find the tension, acceleration, the speed of P when it reaches the ground. So P will reach the ground, Q will move up. Is 2 meters per second. On reaching the ground, P comes to rest, remains at rest, does not rebound. Q continues to move up the slope but does not reach the pulley. So let's say this goes down this much, this goes down this much, and then it goes down further up till here. Find the time taken from the instant that the particles are released until Q reaches its greatest height above the ground. So now this is 0.6 g sine theta minus tension is 0.6 a. Tension minus 0.4 g sine theta is 0.4 a. Add the two, we get acceleration as 1.6. Initial velocity is 0, acceleration is 1.6, v is equals to 2. Find the time, find the distance. V is equals to u plus at, you find the time. And then distance might have been calculated somewhere else. And now tension is 0 because the string slack. So again, acceleration is -8. The final velocity of the previous part becomes the initial velocity. Acceleration is negative. Final velocity is 0. You get t is equals to 0.25. So first it was moving 1.25 as a system. Now it's moving 0.25 as a free particle. So final answer is 1.5. So now let's talk a little bit about work energy power. So work energy, work as force into distance moved in the direction of the force. If the force is horizontal, it's force into distance. If the force is an angle of theta, so that the horizontal component into the distance. If the force is vertical, then the distance needs to be vertical. Work done against resistance, resistive force into distance. Work done against friction, friction force into distance. Work done against gravity, gravitational force, weight, mg, into distance. So we're just focusing on the basic formulas. Energy, there are two types. The kinetic energy by virtue of its motion. The formula is this. Potential energy by virtue of its position. That is mgh, where h is the vertical height. Or mg sine theta, the component along the plane into distance. Now, some people think these are two different things. They are not two different things. They're exactly the same thing. M and G is common. That means h is d sine theta. Sine theta is h over d. Therefore, h is d sine theta. Of course, it's exactly the same thing. If we have the vertical force, we will multiply it with the vertical height. If we have the weight component along the plane, we will multiply it with the distance along the plane. That is the simple fact. Principle of conservation of energy when there is no work against resistance. Change in kinetic is change in potential. You can use this, or total energy at A equals total energy at B. Then we can talk about this thing, which is work and energy. The both are involved. So again, I have made some cases over here. Case number 1, it's a horizontal surface. There is no change in what you call height. So therefore, we would say work done is change in potential energy. Let's say if we have this thing, vertical movement. Initially, that's a total energy at the start. Finally, total energy at the end. There is more initially, there is less. Finally, the difference is work done against friction, work done against resistance. So total energy at the start minus total energy at the end is work done against resistance. For example, if we are starting from the top, a particle is released, kinetic energy is 0, potential energy is mgh. If it reaches the bottom, kinetic energy, of course, is there, but potential energy is 0 because from the perspective of this is the base level, you are measuring the height. So potential energy at the base is always 0. Total energy at start minus total energy at end is work done against resistance. What about if it's going from top to bottom? That's the same thing. If it's going from bottom till up, then bottom will be the start. The same thing for an inclined plane. For example, a rough slope length 5 meters is inclined at an angle 30 degrees to the horizon. A body of mass 2 kg is released from the top. So it's released from the top, so it's top to bottom. So always make a habit of writing. Top is the start, bottom is the end. Potential energy at the bottom is 0. Since it's released, kinetic energy is also 0. Potential energy at the top, that is mg sine theta into distance along the plane. Kinetic energy at the bottom, it's half into m into v squared. So the difference is the work done against resistance. If they're asking for the resistive force, yes, they are. That is resistive force into distance. So this difference divided by 5 will give me the resistive force. Now, this is the most important one that people get stuck a lot. That is this thing. Case number 4. It could be a vehicle, it could be a cycle, a lorry, a car with an engine, or it could be an external force doing work. And we will see 2 examples of this, proper past paper questions. So now it says work done by engine, work done by the external force, that is always positive. Just write it on the left hand side with a plus sign. Change in kinetic plus change in potential plus work done against resistance. Work done against resistance is also positive on the right hand side. Now for kinetic, there are 3 options. For potential, there are 3 options. If there is no change in speed, change in kinetic is 0. If there is no change in height, change in potential is 0. If speed increases, kinetic energy is positive. If height increases, potential is positive. If speed decreases, kinetic is negative. If height decreases, change in potential is negative. That's a simple rule. Now let's look at this question. Now, when you read a question, always make a habit of underline things on the sidelines. So now over here, that's the mass of the lorry. It climbs from bottom to top, straight hill of incline 1000 meter, constant speed. Top of the hill is 20 meter above the level of the bottom. So that is 20 like this. And this is 1000 like this. And then it says the driving force is constant. Find the gain in gravitational potential energy. Potential energy, they call it gravitational potential energy. The work done by the driving force, the work done against the force resisting the motion of this thing. So now, first of all, there is increase in height. So change in potential is positive, mgh. Work done by the engine, that is the engine force into distance along the plane. Work done by the engine is given. Change in kinetic is 0. Change in potential is given. You will find work done against resistance. Now over here, the next one. On reaching the top, the lorry continues along a straight horizontal road. So now it's no more incline, it's straight horizontal. That means change in potential is 0. Resistance 1500. Driving force, it's not given. The driving force of the lorry is not now constant, and the speed of the lorries increases from 10 to 25. So yes, there is change in kinetic, that will be positive. The distance is 2000 meters. Find the work done by driving force. So we need the whole thing. We just don't need the left-hand side of the equation. We just don't need the driving force. We need the work done by the driving force. And this is the resistive force that will multiply by 2000. Change in kinetic, half into m into 25 square minus 10 square. Of course, it's positive. Work done against resistance, 1500 into 2000. Put everything in its place and you will find work done by engine. Something like this. This is that external force, the pulling force. It says a box of mass 8 kg is pulled at a constant speed up a straight path, which is inclined at an angle of 15 degrees. This is the angle of inclination. This is the angle of inclination for the force. The box passes through 2 points A and B, where AB is 20 meters. B is above the level of A. So for the motion from A to B, so B is above, A is below. So it's moving from top to bottom. The work done by the pulling force, that is the weight component into the distance that it moves, which is 20 meters. The gain in potential energy, that is mg sine theta into distance along the plane, that is 20 meter. So this is mg sine theta into 20. Change in kinetic. Does it say that it is at constant speed? Yes. So change in kinetic is 0. And in the end, use the equation. You find the work done against resistance. Work done by pulling force, that's this. Work done at the change in potential energy, that's this. Work done against resistance, make it the subject of the equation. So now over here, let's talk about power. Power is rate of work done. Rate means with respect to time, work divided by time. But work is force into distance. Distance over time is speed. So power is force into speed or force into velocity, whatever is that instantaneous thing. Work is power into time. Force is power over velocity. Time is work over power. So all these things, they can make the subject. A very common question that is being asked a lot. A car of mass 1000 kg travels along a horizontal straight road with its engine working at a constant rate of 20 kilowatt. So this is power. This is the speed. Power over speed is the forward driving force. This is the resistive force, 600 Newton. Acceleration, when its speed is 25, that is the acceleration. Resultant force is mass into acceleration. Something like this. A car of mass 1250 kg travels down a straight hill with the engine working with a power of 22 kilowatt. 3-degree incline and resistance is 1130. Find the speed of the car at this instant. So this is 22,000 divided by V. That is the force that is pulling it down. The weight component is also pulling it down. The resistive force is trying to stop it, but still it's accelerating downwards. This plus this minus this is mass into acceleration. This plus this minus this is mass into acceleration. Very simple. Now, when we talk about momentum, that is the concept. Let me just go to a past paper question. That is this principle of conservation of linear momentum. That is the total momentum before collision is the same thing as total momentum after collision. So this is particle, let's call it A, this is B, this is A, this is B. So M1 into U1, M2 into U2, that is equals to M1 into V1, M2 into V2. Okay, just focus on this. Now, you consider one direction to be positive, the other direction, the other velocity will be taken as negative. So make a habit of writing this one as positive V, this one as negative V. A particle of mass 2 kg travels at a speed of 5 meters per second. It collides with a stationary particle of mass 8 kg. So stationary particle. After the impact, the 2 kg mass has a speed of 3 and its direction of motion is reversed. So now this will become negative 3. Find the speed of the 8 kg mass after the impact. So this is m into v, 8 into 0. This is 2 into negative 3 because of the reversal, 8 into v. If v comes out to be positive, that means it's moving in this direction. If v came out to be negative, that it's moving in the opposite direction. Now the word coalesce, it means the two particles, they combine and become one single particle. So now over here, it says there is 2 kg, there is 3 kg. They are moving towards each other, moving towards each other. This is u, this is 2u. If you take this to be positive, this has to be taken as negative. The two particles collide and they coalesce. That becomes one single object. They continue to move in the initial direction of B. Initial direction of B, that is this way. So therefore, you would write this thing. At a speed of 4, calculation-wise, this will be written as negative 4. Find the speed of u. That's how the system. Total momentum before collision, total momentum after collision. Something like this. Okay, let me start off with a simple thing. It says small smooth spheres A and B of equal radii of masses 4 kg and 2 kg lie on a smooth horizontal plane. Initially, B is at rest. A is moving towards B with a speed of 10. After the sphere collides, A continued to move in the same direction, but with half the speed. So this is half VB. Half the speed of B. So if this is VB, this is half of VB. So 4 into 10, 2 into 0, 4 into half VB, 2 into VB. We find the value of VB, we find the value of VA. Then it says a third small smooth sphere of mass 1 kg with the same radius as A and B is at rest on the plane. B now collides directly with C. So B is there moving with VB, VB is 10. So B now collides directly with C. It was initially at rest. After this collision, B continues to move in the same direction, but with one third the speed of C. So this is VC, this is one third of VC. Show that there is another collision between A and B. Very nice question. So now A is moving towards B. It has a speed of 5. This has a speed of 10. Let's see what is the working that's required. So now over here, this is 2 into 10, 1 into 0, 2 into 1 third VC, 1 into VC. VC comes out to be 12. VB is 4. Now the speed of B is 4. Since VA is greater than VB, VA is 5. That means it will overcome and collision will occur. That is the thing. Now over here, A and B coalesce during this collision. Find the total loss of kinetic energy in the system due to the 3 collisions. So now this thing is that this is A, this is B, this is that second collision during this collision. Now over here, this is 4 plus 2, 6 into B. This comes out to be 14 over 3. Initial kinetic energy, that is half into 4 into V squared. Final kinetic energy, that is initial kinetic energy at the beginning of the journey. Find the total loss of kinetic energy in the system due to 3 collisions. Now, in this collision, they coalesce. But the loss they are asking about, that's a 3 collision. So initial, only A had kinetic energy. B was at rest. C was at rest. That is this value. Final kinetic energy. That is the final kinetic energy of A and B, the final kinetic energy of C. These two, they coalesce, and C is also there. The difference between this, that is the answer. So I think that's all about it. And we discussed every single chapter in whatever detail we can. And wish you the best of luck in M1. Just follow the instructions that I've given you about forces, about these kinematics, laws of motion. The instructions were given already over there. In work, energy, and power, it's all about these equations. In momentum, it's about the principle of conservation of momentum. So that is all about it from my side. Take care, everyone. Allah Hafiz.